Hello, welcome, welcome. If you are watching this, you've made it to Astronomy Online, Secrets of the Eclipse, and I'm so excited to have you here. My name is Soleil Estevez, and I am so happy to be your host for today's space show. And, just a few announcements before we get started. If it's your first time, just to make sure you are comfortable and you are excited for today's program and know what's going to happen. And then, of course, some few reminders if you've been joining us every month for these Astronomy Onlines. So the first announcement is, as always, we are paying very close attention to the live chat for this program. And we want you to, feel free to ask your questions throughout the presentation, say hello. If something is not, making sense, or if you want to look at something closely, let us know in the chat and we'll bring it up on screen and try to show you live. I actually see that the chat is quite active right now, but let's even warm it up even further. Let us know where you're tuning from today. So just type it in the live chat, what country you're from, what state. We have people joining in from all over the world for these. Maybe you're signing in from your school. So if you're doing that, maybe let us know what school you're from so we can say hello. I also want to let you know there's someone really special in the chat today. Her name is Johanna Voss, and she's an astrophysicist. So if we don't get to answer your question live on screen, don't worry, because Johanna will be answering those questions for you in the chat. So be sure to pay attention to those. I also want to let you know that the museum is open. And if you didn't know that already, we hope that you will come visit us for a timed ticketed entry slot. You can plan your visit at amnh.org. The Hayden Planetarium is still closed for now, but rest assured you can still visit the planetarium virtually with us every first Friday of the month at 1 p.m. on this YouTube channel, where we're going to continue bringing the Hayden Planetarium to you. I would also check out our calendar page on the website, right there, amnh.org, to see all the upcoming events we have, not just in astrophysics. Alrighty, those are my only two announcements. So I'm so happy to get started today and introduce our presenter for today's space show. You might recognize her from past events. Her name is Jackie Faherty. So here we go. Let's bring her on screen. Hi, Jackie.
Hi, Soleil. How are we doing?
I'm doing good. I'm so excited to learn about all these secrets of the eclipse.
Yeah, secrets of the eclipse. And I can see I'm monitoring the chat. We have people from all over the world, which is always critical when you're going to talk about an event or events that can be seen from different spots on the world. So for those writing from Florida, the Philippines, Brazil, wow, Australia, we're very excited that you're here.
Welcome.
Yeah, welcome. And Soleil, you're going to be monitoring the chat closely, right? So that everybody will have a chance maybe to chat with us.
That's right. So I'm going to leave you for now, but I will be popping in throughout the presentation with your questions. So definitely put those in. And Jackie, I'll see you in outer space.
Yay. And I just saw Loretto is writing from Temuco, Chile. We will be paying attention to you. And you're going to get a special shout out because Chile is getting some eclipse action very soon. But hi, everybody. I am very excited to be your presenter today. And I will be telling you all things about secrets of the eclipse, things that you might know, things that maybe you've never thought about. We've got several secrets that we will be revealing as we go. Helping me out today is for the very first time, is a very special pilot, Deion Desir. Deion, I think you get a viz check-in here. Look who we have here.
What's up, everyone?
Deion is, well, Deion, why don't you introduce yourself? Because you can do it better than I can.
Yeah, that's fair. What's up? It's really nice to be on the stream with everybody. My name is Deion Desir, and I'm an open space pilot right now, but I'm also a New York City public school teacher. So shout out to all of the hardworking scholars right now, especially considering like how tough it is to be going to school, but specifically to the Eagle Academy kids. This one goes out to you. But I met Jackie through the Natural History Museum. I'm also a alumni from the Masters of Arts of Teaching program in Earth Science. So shameless plug, check that out if you haven't heard of it yet. It is a fantastic teacher prep program where they give you all the tools to succeed. You are engaged with some of the best educators and also the scientists that you're actively, learning about. So it's really an amazing opportunity. So check it out, amnh.org/MAT.
Yes, and the special shout out I will give to Deion is that he was one of my master's students working with me over the summer, doing research with me. He's been on peer-reviewed publications in astrophysics journals. He's been doing visualization work with me since this summer through to today, which is why he is going to be an amazing pilot for this program. And I think we should just jump right into it, right, Deion? We should just get into open space. The other important thing for you to know is that we will be using this open space software. It is all open source. It is NASA funded. We've been developing it with various partners around the world at the American Museum of Natural History. And you can download this software and play with it the same way that Deion is going to be flying through it and that I'll be talking through it. So that's to encourage you both if you're students and you get excited about this, but if you're a teacher and you're like, I could totally teach with this material, I think that this is great software for you, which you feel, right, Deion, since you're an earth science teacher?
Absolutely. There's nothing better than representing it actually how it works, visually.
Yeah. All right, so let's get started. So we're starting here, and to give you a layout of the program too, this is going to be in 3 acts, this program. Act 1 is going to be, we're going to start on the Earth, and we're going to fly outside of it and look at the Earth, Moon, Sun system. Then we're going to come back in and witness some eclipses here on planet Earth of past and future. And then we're going to move outside of the Earth, Moon, Sun system into the solar system. So get ready for the 3 acts. And throughout, we will reveal 8 secrets of eclipses. 8 secrets. Pay attention to all 8 secrets as we go, ladies and gentlemen. All right, so Deion, we have us started here hovering over the American Museum of Natural History in New York. And this is a viewpoint right around sunrise. What day do we have it set to, Deion?
This is November 26, 2020, so Turkey Day that just recently passed.
Turkey Day. And the reason why we set it to that actually is for those of you that are in Manhattan or maybe in New Jersey, if you had looked east on Thanksgiving and then on the 27th, 28th, and 29th, you would have been greeted with a morning Manhattanhenge, where the sun actually rose aligned with the grid of Manhattan. So if you had been looking east, you could have viewed this event, and it's coming back to you in January. So if you're an early riser, or even if you aren't, look out for this fun event where you get a sunrise along the grid of Manhattan. But this program's all about phenomenon that happens with the sun, and specifically eclipses. So we need to talk about the Earth, Moon, Sun system. So let's just fly right off of planet Earth here. Dan's going to lift us off of the planet where the grid of New York comes to life. So do the outer boroughs, and then the whole northeastern seaboard will come into view for you. As we move away, you'll see Long Island stretch out, and the Canada comes in. There, we just came across Cape Cod, then comes Canada, and now we're getting that viewpoint, which would be so amazing if all of us were astronauts, which would be a viewpoint from outside of planet Earth as we're orbiting. Let's just pause here for 1 minute, Deion, and just take this in. So one thing is we're viewing the Earth from above, as we would if we were astronauts. And that blue line that you see coming off of the Earth is the line that represents the orbit that the Earth is in as it's going around the sun. And we can keep on kind of coming out, Deion, because what we want to talk about is the Earth is not alone, is it? It has a partner. It has what I like to call a celestial partner. And key to this is the following. Here comes the Earth as we move away. Now we've reached a distance. This is pretty good. Let's go to our bird's eye view, where there's the Earth, and there's the pink line going around is the moon. The mass difference between them is like a 1-to-4 ratio. The Earth is like 4 times larger than the moon is. More important is secret number 1 of the eclipse. And that is that the sun compared to the moon, the sun is 400 times larger than the moon. But the moon is 400 times closer to Earth than the sun is. That means that the moon and the sun appear the same size in our sky. So you could walk outside and cover the moon with your hand, with your finger, actually your thumb, and you can cover the sun. You don't see the difference in your apparent, in the apparent size on your sky because the distance versus the scale are pretty close, which is crazy. And that is why we can get total solar eclipses, why the moon can actually pass in front of the sun. Let's increase the sizes, Deion, and you can tell us how much bigger so that we can actually see the moon from this perspective.
Mm-hmm. So the beauty of this program is that we can alter things to how we need it. So right now I'm changing the size of the Earth to 15 times its size. And then also the moon, I'm going to change it so it's 15 times its normal size. So that way we can actually see, as things are going around, what we're trying to point out. Because otherwise, that was pretty hard to see before, I'm assuming.
Yeah, there's our moon there. And let's see it going around too. This is critical. Now, the actual distance of the moon from the Earth is about 250,000 miles, like 240,000 miles or so. And any good earth science teacher can tell you how long does it take the moon to go around the Earth, Deion?
It takes approximately 27.3 days to go around.
Now, this one's not one of our secrets, but it's a fun fact. And most people have that in their heads that it's about, it takes almost a month for the moon to go around and you can see all of its phases. Also critical to this as you're watching the moon go around the Earth is that the same face of the moon is always facing us, always. So we have the face of the moon that faces us is the near side, and the one that doesn't face us is the far side. People like to call it, because of various bad things in astronomy, the dark side of the moon, but it is not the dark side, right, Deion?
No, it is the far side.
Far side. Let's try and get that one in our heads. But so Deion's got us moving around, the moon going around the Earth in this nice way. The sun is the flashlight that's lighting up the Earth, so you can get an idea based on the bright side of the Earth where the sun is. And now he's moving us into this position, which leads us to secret of the eclipses number 2. And that is that the moon, as it's going around the Earth, is tilted by 5 degrees, just about 5 degrees. The moon's orbit around the Earth is tilted at 5 degrees, which means that from this perspective, that pink line, as you can see the moon going around the Earth, you'll see that the moon is sometimes, the pink line represented here, is sometimes above the blue line, which is the Earth's orbit around the sun, and sometimes it's below it. So it's just off by a little, just about 5 degrees. And that leads us to not having a total solar and a total lunar eclipse every single month. I think that's a pretty cool secret that we've just revealed to you, and it's a critical one for understanding eclipses. The other critical thing, which we can see from out here, is secret number 3. These distances haven't always been like this. So when the moon was first formed around the Earth, it was actually only about 12,000 miles away from us. Can you imagine that? That would have been very intimidating. Now it's 250,000 miles away. But at some point, the Earth is going to see its last total solar eclipse. Why? Because the moon is actually moving away from the Earth due to tidal interactions that are going on between the Earth and the moon at a rate of roughly 3.8 centimeters per year. So it doesn't sound like a lot, but astronomically speaking, enough time will go by where the moon will be so far away that it will not be large enough in your sky to be comparable to the sun, and you won't have a total solar eclipse anymore. Hopefully that doesn't make you guys feel sad. Soleil, it looks like you're here to tell us people are sad.
No, I'm not. I'm actually here with an excellent question.
Let's hear it.
All right, so we have a question from an Austin Lynn about the degrees you were talking about. And his question is, what if it was tilted 5 degrees the other way?
Ah, great question, Austin. And that would just change the dates of those eclipses that you would see. So right now it's 5 degrees you could think of north, but you could have it 5 degrees in the other direction. And if it was, it would create a similar effect, but the dates of your total solar eclipses and your total lunar eclipses would probably be a bit different. I think important also to answering that is we don't really know why it's tilted at 5 degrees. We look for that kind of number to give us some hints at maybe what would have happened between either the Earth-Moon system when it formed, maybe the moon got hit by something and put it off kilter. All of those things, all of those stories could be told by looking at numbers like that astronomers look at and get interested in.
Awesome. Thanks so much, Jackie. And don't forget to ask more questions. We'll be popping them in throughout the press.
Yeah, and I love where I'm seeing you guys are all coming in from students from Nashville, students from different parts of the world. Please keep telling us where you're watching from too, because we're going to now dive in. Let's get a little bit closer now, Deion, and we can stop time and come in. So Deion's going to set us up for a view of, and we should say the Earth and the moon are very large right now still, right, Deion?
Mm-hmm. I'm scaling them back now.
Scaling them back. That is part of the great things that we can do in open space is change the size of objects like the Earth and the moon there so that we can have that more of a visually effective view for you as you saw. Perfect. And now we'll go back in. And as we do, I have a question for the chat. And that is, has anyone in the chat ever seen a total solar eclipse? And you can answer with both have you seen it and where you've seen it from. And if you've seen a total solar eclipse or if you've seen it, you can say a total lunar eclipse. We're very much on total solar eclipse right now. But here's a key thing that I usually use when I ask people that question. If your answer to that question of have you ever seen a total solar eclipse is yeah, I think so. I'm pretty sure you haven't seen one. If your answer is maybe when I was a kid, I'm pretty sure I saw something like that. No, you also haven't seen one. Because if you have seen one, your answer is, oh my God, yes, I have seen one. It is so crazy. Because it is literally so crazy if you've seen a total solar eclipse. I'm seeing a couple of people answering with some mentioning the exact thing we're going to show you, the year 2017. Deion, let's set our clocks. I think you know what date to set it to.
Mm-hmm. August 21st, 2017. So as I'm changing the time, you might see things moving around. That's because we weren't in the same position that we were before.
And we're going to move time backwards just a little bit. And so Deion's got us set up. So those that might remember, August 21st, 2017, there was a total solar eclipse that crossed the United States of America. So it was called the Great American Eclipse. And we are going to, from this bird's eye view out here, simulate what that would have looked like if you had been watching the eclipse happen from space. So Deion, let's set time to 5 minutes a second. What have we been setting it to? So this is also the power of open space. We can make time move at the rate that we choose.
Well, let's start off with 10. And if it's too fast, we'll go to 5.
All right, let's start out with 10 minutes per second. Every second, 10 minutes will go by. And we're starting you right before the eclipse were to happen. And the Earth will turn. And it will soon invite for us the shadow of the moon. There it comes. And what that giant shadow is showing you, that from the locations that giant shadow covers on the planet, you would be able to see a partial eclipse. You would see a part of the sun disappear from your perspective. If you were wearing protective eye gear, protecting your eyeballs because you're never supposed to look at the sun. Now let's go back and do that again. And let's do it at 5 minutes a second, Deion, as we go across this time. So what I want you to look for is at the center of that giant circle is a very dark core. And that dark core, which covers an area which is roughly like 50 to 70 miles, I think it was 70 miles wide for the 2017 eclipse. Anybody that is on this 70-mile dark core at the center of this moving shadow would have seen the sun disappear behind the moving in new moon. And a very exciting event. Now, I'll give you secret of the eclipse, number 4. That is, how long will that have happened for? Well, the longest possible eclipse that you can get on planet Earth is only about 7.5 minutes where the sun will disappear behind the moon. Only about 7.5 minutes. The shadow moves very quickly across the Earth. The solar eclipse on this date of August 21st, 2017 only lasted in its maximum spot on the totality line about 2.5 minutes. So for people that were on that line, they would have seen 2.5 minutes of the eclipse. Soleil's back.
Yes, I do. We have a really interesting question that I think will go well around this time. It's from Jade, and her question is, why are some eclipses longer
Great
than
question.
others?
And that comes back, that's a throwback, Jade, to what we just saw in the Earth, Moon, Sun system, where the moon, as it goes around the Earth, is at a different distance because it's in an elliptical orbit. So if the moon is closer or farther away, it means that the shadow will be bigger or smaller. Also, it will be moving faster or slower in the orbit because when it's particularly close to the Earth, while it might be a little bit bigger, it moves faster because of Kepler's laws of planetary motion. When you're closer, you move faster. Mercury moves faster around the sun than we do. And so because of that, oh, Deion, you've got to set us up really well here. That shows you this back view of the moon chasing itself around. So it's all about how close the moon is to us during that solar eclipse. That will set that. Great question, Jade, though. But let's come back around because, Deion, you were watching the eclipse of August 21st, 2017, right?
Mm-hmm. That I was. I drove down from New York City all the way down to Nashville, Tennessee, because like you were saying, there wasn't many places where you're getting totality, and I really want to experience it. So drove down to Nashville after 14 hours and was able to check it out.
And let's see some of the pictures Soleil has queued up.
Yeah, you can see in the left photo, there's kind of like a sunset that you can see. That was all around 360, and it was about, I believe, 1 or 2 p.m. So you shouldn't be seeing a sunset. It was really a visceral feeling. I actually, in the right photo, forgot to take off my protective glasses to take the selfie. You know, I was just being safe. But it was one of those groundbreaking moments for me. Body shaking, crickets going, stars started to pop up a little bit. It was a fantastic 2.5 minutes.
And you were there with other master's students from the American Museum of Natural History, right?
Mm-hmm. We all got into a car and drove down together. It was really beautiful.
Great. I was in Casper, Wyoming, and I think we have some pictures from where I was. Now, on the left-hand side, that's actually an image that I took from a sun spotter telescope, which is showing you that bright white ball is the sun. And that I keep describing it as like the Death Star coming in. It was taking chunks out of the sun, which it still looked like daytime, even with that much of the sun removed, but just started to feel colder and it looked more like a cloudy day. And then to the right is my nephew, Elliot, who I had taken with me that was wearing his protective eye gear. I was making sure everybody around me was wearing protective eye gear. And in the moment of totality, just like Deion just showed, it looks like dusk all around with gorgeous pink. Stars came out, Venus came out, and Soleil, our next image here is what the sun ends up looking like. So this is right at that very last moment where the last bits of sunlight are trying to make their way to planet Earth via the valleys on the moon. We typically call this moment the diamond ring effect, where you get this last bit of sunlight coming in right before that corona, the all around the disk, which you're seeing, basically the moon in front of the sun here, is the plasma of the sun, what we call the corona or the crown of the sun, which is this hot plasma that just comes off of the sun in all directions. And this is what it looked like. And this is why you guys, if you've seen one, you know you're going to remember it because it is very, very strange. Right, Deion?
Oh, absolutely. As you're looking through it with your protective glasses, of course.
Well, so right, we wear our protective glasses until the moment of totality, and then you can remove them and actually look at it. So for those I've seen in the chat, people are from all over, especially our friends in Chile. And if there's anybody in Argentina in here, please give a shout out because what you have coming, ladies and gentlemen, to a date that Deion is about to set us to is a total solar eclipse in just 10 days. 10 days. 10 days. 10 days is the next total solar eclipse for those that are in South America. It will be a partial eclipse, and you'll see where you can watch that from as the shadow comes across the Earth in this fast-forwarded simulation. So now we've moved time forward to the date of December 14th, 2020, this year. We're focused on the continent of South America, and Deion is going to start running time so that we can see, let's see this happen, Deion. This moment.
Right there. Boom.
Here comes the larger shadow, which would show you that where you can be on the planet. So those of you across South America will get a partial solar eclipse. Only those in the south of Chile and Argentina. So if you're around the Puerto Montt area, in southern Chile and sort of like the northern Patagonia area, you will get a total solar eclipse. And look at that. The dark part, the dark central area will pass over a thin little area of southern South America in just 10 days. 10 days, ladies and gentlemen. If you're there, get ready. And here comes another secret for you. Secret number 5. This is a fun one. Lunar eclipses chase solar eclipses or vice versa. So those of you watching this might be like, didn't something just happen last weekend? Yes, we had a total solar eclipse, which was very viewable for those of us in North America. It was a penumbral eclipse, so the alignment was not perfect. The moon didn't actually pass perfectly through the darkest part of Earth's shadow, but it did happen. And immediately that if you saw that, you might have thought, total solar eclipse is coming, because lunar eclipses and solar eclipses chase each other. Other secret, which comes right after this one, secret number 6, which is very, very visible in this other view of the December 14th total solar eclipse, is that more than 70% of the Earth is covered by water. And the line of totality for a solar eclipse, only about 50 to 70 miles wide. So for any given location on Earth, a total eclipse only happens about once every 100 years or so. So you might be thinking, when's my next chance? It might not happen in your lifetime that a total solar eclipse will pass over your household or even a place that you can easily get in the car and drive to. So just keep that in mind. The Earth is over 70% water. A lot of eclipse chasers, total solar eclipse chasers, get in a boat and boat around and look for eclipses, because more than likely you're going to have your total line of totality that's going to cross water.
Yeah, look at this. I'm not doing anything. The Pacific Ocean is just massive.
The Pacific Ocean is just massive. Yes, exactly. All right. So with the last bits of the program, and look at that, you've got it nicely lined up so you can see how this eclipse does cover some of the planet.
Hi, Jackie. Maybe before we move on to the next part of the program, can we take some questions? We have a lot of general eclipse questions that I thought we might tackle. So the first actually comes from Alexander Hoffman. And so I know that we talked about eclipses happening on certain places on Earth, but his question is, can we see eclipses everywhere on Earth? Is it possible to see eclipse at any given location?
As long as you can see the sun and you've seen the moon, you know that you can get them lined up. That's a great question. So there's a lot of ways to answer this that I wish I had statistics for you of how often, what's like the location on the planet that's had the most luck at total solar eclipses. I want to say also that there's another eclipse coming for the United States, and Carbondale, Illinois, which just was on the center line for the 2017 eclipse, is going to get it again. They'll get another one. So when I say that it's every 100 years or so, that really just means that's just like a statistic, which means that you could, in theory, get a total solar eclipse more than once in a 4-year period or in a 3-year period. Chile just got the total solar eclipse of 2002 years ago, so 18. So you can get them anywhere on the planet, but the statistics of how often you get them are kind of random enough. And the 100-year thing is just rule of thumb, if you will.
And that actually goes into Abigail's question and wondering, when the next full solar eclipse might happen in America. And I don't know if there are any tools that we can share of where people can look to find when the next eclipse might be.
Yeah. So April 8th.
Yes, April 8th, 2024.
April 8th, 2024 is the next really good one for the United States, where we're going to have a total solar eclipse that will cross from, it'll start in the southern Pacific Ocean and then cross the United States from Mexico through Texas, then up across towards the Northeast. So New York's actually going to get it. Rochester will certainly be in the center line, and it'll go out through Canada and then over the Atlantic. And that's in just 4 years. So something for everybody on here to look forward to. And I would suggest, and Sully, we may even have the link ready to go, that timeanddate.com is a place that I go to all the time. And I look at my exact location, and it'll tell you eclipses from the past and the future. Because you might be thinking, I think there might have been one, and I missed it. Especially for the older crowd in here, you might remember an eclipse. And this will allow you to look that up.
Mm-hmm. On Open Space right now, just quickly set it to 2024. So if you're anywhere where that dark circle, remember, just the center of it is where you find totality, it's going to, you'll be able to experience a total solar eclipse. So this trajectory is a little bit different. It's much more like northeast bound, but upstate New York is going to get it. I know some parts in Maine and Canada. So you don't have to drive south 14 hours to see this one.
Yeah, I would suggest starting to look at booking your travel for that, as soon as travel restrictions become more realistic. A year, 2 years, even 3 years in advance for eclipse viewing is recommended, as places know that people will flock there, as those that tried to get a place during the 2017 eclipse might attest to how crazy it becomes, since it's an event you want to see at some point in your lifetime. But I think we should move outside of the solar system now, because now, or not outside of the solar system, I should say, outside of the Earth, Sun, Moon system, since we've been very focused, number one, on the solar eclipse, because it is so epic. The lunar eclipse is also very exciting. It happens on the opposite side of when the moon is on the other side of the Earth, and it passes in the shadow of the Earth. We call those total lunar eclipses. The moon will turn like a reddish color, and that's very exciting. But what I really want to talk about is that the eclipses are not special to just our little system. So let's move out and get a bird's eye view of the solar system, Deion, which takes me of the whole solar system. Yeah. So now we've got the sun at the center, seeing stars in the outer area there. The Milky Way is just off to your right. The inner solar system is very clear here. Mercury is the first planet, Venus, and then Earth in blue, Mars, a big gap, and then it's Jupiter. And we can move a little bit further out to see the other Saturn, Uranus, and Neptune. And we'll come in just a little bit closer. And then let's turn time on. Let's turn time on at a rate of I don't remember what we agreed on, but maybe...
You want to do a month a second, or?
Let's do 100 days a second so that we can really see the outer planets move. So this relates to a question that was asked about how fast you would see a total solar eclipse. Oh, and I think we want to change to focusing on the sun to make sure we don't wobble around the earth there. And notice how you're seeing all of the planets orbiting the central star. And that's what they're doing. They're going around and around in the merry-go-round of our solar system. And each of the planets might have the opportunity to have an eclipse if it had a natural satellite. In our own solar system, in the inner solar system, actually we'll start there, Mercury and Venus do not have moons, so they can't have eclipses. Mars and Earth do, but Mars's moons are too small and too far away to have total solar eclipses. But the other planets are fair game: Jupiter, Saturn, Uranus, and Neptune. So we're going to fly on into Jupiter and have a look at that amazing mini solar system that exists. So Deion, why don't you take us in towards Jupiter? And that is taking me to eclipse secret number 7. Earth is not the only world in the solar system that can have an eclipse. Any planet with a moon or a natural satellite can have an eclipse with the right conditions. Then that goes to my point that Mars has 2 moons, Phobos and Deimos, but they're too small, too far away to eclipse it. So they don't get total solar eclipses on Mars. It only gets partial eclipses. But here we are at Jupiter, right, Deion?
Yep, this is Jupiter, and it's many moons flying around it.
Many moons. Look at that. And that's just a couple of them. It has something like 70 moons, and we still seem to be finding the moons around Jupiter, even though we even have spacecraft that are orbiting Jupiter right now. The Juno mission is currently in orbit around Jupiter right now. But we still seem to find moons. And Deion's taking us in, and we kind of on edge on the Jupiter system here. And let's move in just a little bit closer and tell me what date you're going to set us to, Deion, because you've got this in your head.
Oh, yeah. So we're going way back. We're going back to 1997. Let me pause for a second so we don't spoil it. But we're going back to 1997, where we were able to grab I don't know if we have a photo of it, but using this software, we figured out that there was a moment on Jupiter's face that you get multiple eclipses at the same time. So we're at November 11th, 1997. Sorry, having some tech difficulties.
As you set that up, I just want to note Jupiter has many, many moons, but it has 4 very, very famous moons. I'll give you guys a second if you can name them in the chat, if you know the names of these moons. And I think we'll start a little bit further in time too, Deion, so we can actually watch it come on. If you can name the moons too, there are 4 special ones that I'm thinking of right now. And those are the ones that we are going to be playing around with right now that you're going to see. Jupiter has, they're categorized as Galilean moons. Oh, I see Bob Kaplow has answered. Io, Europa, Callisto, and Ganymede. That is correct.
Woo!
These are the moons. Now, Deion has set us to what? How much time is going by, Deion?
We are moving at 10 minutes a second.
10 minutes a second. And check that out. You're getting a triple eclipse across different areas on Jupiter, which is pretty awesome and shows you there's nothing really special about the Earth-Moon system in many ways. You can get these conditions throughout the solar system. Jupiter has this amazing setup where you can get not just 1, not just 2, not just 3 even, you can get more eclipses happening on its face. And a lot of that will come from the moons that are closest and largest, and those 4, Io, Callisto, Ganymede, and Europa, are the 4 Galilean moons that orbit close by, and they're named after Galileo as he noted them orbiting around Jupiter, similar to how our planets orbit around us. And Deion gave you a nice view there, looking back towards the sun, shining with the moons between you and your spot viewing on Jupiter there.
Or at least attempted.
It was a good attempt. I like it. And we're going to end on a final secret. And that is that this is us in Jupiter. Jupiter's view, which I think is the coolest place in the solar system to watch eclipses happen. But if you move outside of our solar system, and here's your secret, number 8, it is possible for planets outside of our solar system, they can have planets of their own that eclipse, but most importantly, they can have a viewpoint from their spot of our solar system moving in front of our sun. Now, it's too far away. We're too small and the distance is too large. We're not going to eclipse the sun for them, but we are going to do something called a transit. So an eclipse that's super far away so that you're not actually seeing a total shadow of the one object over the other is called a transit. And we see this all the time as astronomers when we're looking for other planets that might be transiting their own sun. And so Deion's kind of taken us out. Why don't we line up, Deion, with a view so that you can see there's our solar system. That's a thin line. And notice there's stars around the sky, but there's actually way more stars here than we're showing you. These are only the stars that you can see with your eye for the most part. Deion, why don't you turn on the Gaia data set? Gaia is a European Space Agency spacecraft that has been monitoring the positions of stars. So that brought up a couple more stars for your eye. And now let's increase the brightness of these, Deion. So let's make the brightness on these, instead, their luminosity, let's amplify them by about 100.
Oh, and that's very bright.
Yeah. So now what you're seeing are all of the stars that we have been mapping. We have been mapping these stars across the sky, and any star that falls along that line, and let's zoom in just a little bit closer to our solar system so that the lines become clearer. Any star that lies along the line, the orbits of our planets around the sun, could look towards us and watch our planets pass in front of our star. And that means that we are a detectable world. We are detectable as a transiting world, not an eclipse because we don't have the right size and it's not the right distance, but we transit. So we are detectable. Think about that one. That's a fun thing to think about regardless. I think it's an amazing thought process to consider. All of these stars may have planets. They may have solar systems with interesting eclipses around them. But interestingly enough, the ones that are on that line can see us going in front of our sun. That makes me both feel uncomfortable that we can be detected, but also it's a sense of peace that's how the universe works. Deion has us moving out and away a little bit so that you can see the breadth of how far away these stars are. And I think that's a good place. This is a good vision for us to stop and take any more questions that you guys might have too about eclipses.
Hi, yeah, there are actually a question that just came up that you did talk about. Let me see if I can find it here, about whether exoplanets can have eclipses.
Yeah, exoplanets can very well have eclipses. And interestingly enough, one thing that we do when we search for other worlds is we look for them, a planet passing in front of its own star, say the transit, but then you would look for a second little blip. And that second little blip would be a moon around a planet. So certainly a planet around another world can have a moon. And we are just literally at the bleeding edge of that aspect of science right now. That's a good place to promote too, that we have a Frontiers lecture coming up, Soleil, right in a week, 2 weeks.
That's right. Actually, on the 16th of December, It's going to be a noon, a lunchtime Frontiers lecture called Hot Takes on Cool Worlds, where we're going to have Laura Kreidberg, who is an exoplanet specialist, talk about all the latest and most recent discoveries about exoplanets. So we'll put the link in the chat for anyone who might be interested in joining us for that.
That is the next stage that we are going to get to in exoplanet studies, where we look at the worlds going around the worlds that we're finding. So that's bleeding edge science is what I like to call it, because it's so hard to do, but we can, in theory, do it.
And with that, I do think we are out of time for today. I just want to extend a huge thank you to Jackie and Deion for such an amazing presentation. I learned so much about eclipses and all the secrets that they have in store. And for all of you still with us, if you can take a few moments to fill out this survey, let us know how we did. We'd love to hear your feedback. We're always trying to make these programs as best as we can for you. So we'll drop that link also in the chat. And as we just mentioned, we hope you'll join us on the 16th at noon for our Frontiers lecture about exoplanets. But if not, if that doesn't work for you, we also hope to see you for our first Astro Live or Astro Online of the new year in January on the 8th, which you're going to hear it here first, drum roll, is on Saturn. So we hope to see you on Saturn on the 8th of January at 1 p.m. right here on YouTube. And yeah, thank you so much for joining us, and we hope to see you next time.
Thanks, everybody.
Thanks. Good to see y'all.